We are going on with paper 1 of June 2024, and this is question 4. We are given that gx is equals to 1 over x minus 1 plus 2, 4.1. Write down the equations of the asymptotes of g. So remember, the base formula is a over x minus p plus q. The q value represents the horizontal asymptote, and x minus p equal to 0 represents the vertical asymptote. So what we will do is we take x minus p and then we solve for p. So for 4.1, we have a vertical asymptote where x is equal to 1 and a horizontal asymptote where y is equal to 2. 4.2, draw a graph of g indicating any intercepts with the axis and asymptotes. So we already have the asymptotes, and what we want to do now is find the x and y intercepts. So in order to find the y-intercept, I will make x equal to 0, so therefore we have y is equals to 1 over 0 minus 1 plus 2, and that means that y is equals to 1 when x is equals to 0. And then for the x-intercept, we will make y equal to 0. So 0 is equals to 1 over x minus 1 plus 2. So I'll transpose the 2, so I move it to the other side. And I have 1 over x minus 1 on the right-hand side. Then I will cross multiply, so I'll multiply negative 2 with the denominator. So we'll have negative 2x minus 1, or negative 2 multiplied with x minus 1 is equals to 1. I'll quickly multiply out. So it's negative 2x plus 2 is equals to 1, and then I'll solve for x. So we can see that x is equal to a half. That will be our x-intercept. So let us quickly draw the function. Always draw the x and y axes. Put arrows on your axes and show the origin with a 0. Next, we'll draw the horizontal asymptote and the vertical asymptote. For the horizontal asymptote, y is equal to 2, and for the vertical asymptote, we have x is equal to 1. And can you see I'm not really focused on scale? I just want to have everything in its right position. Next, I'll draw the y-intercept, and that is where y is equals to 1. So on my y-axis, it will go through plus 1. And the x-intercept is where x is equals to a half. So for the hyperbola, we'll have a curve that moves towards the asymptotes. And I'm trying to get my curve to move towards the asymptotes but never touch the asymptotes. And I'll put arrows on my curve. And the same goes for the first quadrant. Now what you can do is you can always substitute a point in on this quadrant or on that curve. For example, x equals to 2. So put x equals to 2 in your equation to find a reference point. So when x is equal to 2, y would be equal to 3. And all that I'm doing is I'm replacing this x with a 2 to get our y coordinate. So notice at 4.2, I have the y-intercept, the x-intercept, I have the asymptotes, and I have the curves in its right position with one reference point. Question 4.3. Determine the values of x where gx is bigger than 0. So let us look at our sketch. So where gx is bigger than 0 is where the curves are above the x-axis. And can you see that we're above the x-axis for every value to the left of a half? So x would be smaller than 1/2. And we're also above the x-axis for every value to the right of the vertical asymptote. So for question 4.3, it is where x is smaller than a half or where x is bigger than 1. 4.4, determine the equation of the axis of symmetry of G which has a negative gradient. So for an hyperbola, you'll have two axes of symmetry, one with a positive gradient, so that is y is equals to plus x plus c, and a negative gradient where y is equals to negative x plus c. So remember, the axis of symmetry either has a gradient of positive 1, or when it's negative, the gradient would be equal to negative 1. So if you think of the format of y equals to mx plus c, for a negative gradient, we already have that as negative 1. Now we just need to solve the y-intercept. And in order to do that, you'll take the point where the two asymptotes intersect, because that axis of symmetry will move through that point. So we are going to use the point 1 and 2 in order to solve our y-intercept. For 4.4, we have y is equals to negative x plus c. I'm replacing y with the horizontal asymptote of 2 and x with 1, and then I can solve c. Therefore, the equation of the axis of symmetry with a negative gradient would be y is equals to negative x plus 3. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.